Yeah, good day to you all. Welcome to another physics class. How is Ramadan? Ramadan Kareem. To my wonderful Muslim students. May Almighty Allah accept it as an act of ibadah. Okay, so today's topic on physics is latent heat. Latent heat. So, what do I actually mean by this latent heat? When you are trying to increase the temperature of a particular material, let's take for instance ice block. You know, ice block has a very lower temperature. Now you are applying heat to ice block will tend to increase the temperature. It will increase the temperature. When it gets to a particular temperature, the solid, which is the ice, starts to melt. That temperature at that particular point becomes steady. So the heat required there is called the latent heat. Sometimes it is referred to as the hidden heat. It's only the temperature we see, we don't see the heat. So there we refer to the heat as latent heat. Latent heat is in two categories. We have the latent heat of fusion and that of vaporization. Now when we say fusion, this simply means the heat required to change a solid to liquid. Latent heat of vaporization means changing a liquid to vapor state. So fusion is solid to liquid. Vaporization is from liquid to vapor state. So now look at the board here. L. Remember that in specific heat capacity we have C as our specific heat capacity. But under latent heat we have L as our specific latent heat. And it's given by this formula, Q equals to mL. Q equals to mL. Now the unit for latent heat is joules per kilogram. Can you see that we don't have anything to do with temperature here? The temperature is negligible. So here it is joules per kilogram. Now for better understanding, let's go to this example. To how much heat energy is required to change 10 kilograms of ice? Who can tell me what ice is? A solid. To water at 0 degrees Celsius. The specific latent heat of fusion, because we already know that we are changing solid to liquid. So the specific latent heat of fusion is 336 kilojoule per kilogram. Mind this one, it is kilojoule. So now let's write out our parameters. What is the mass? We have to change 10 kilograms. Our mass is what? 10 kg. Then our specific latent heat. Remember this one is in kilojoules. So it's going to be 336 times 1000, which is 10 raised to the power 3 joules per kilogram. We've converted it to joules. So from our formula, Q, because we are looking for the quantity of heat, M times L, Fen times L. Calculator, what is the L? We have 336,000. So if you have to look at this, we'll be having 336 and how many zeros? 4 zeros. This is the quantity of heat. What will be the unit? That will be ordinary joules. Have you gotten that? Yes. Any question? And you see, this one is very straightforward. You already have your specific latent heat of fusion. We have our mass. So all we just have to do there is to multiply the mass with the specific latent heat of fusion. So now let's go to the second example. Yes. Now, if 1.13 times 10 raised to the power 6 joules of heat energy is required to convert 15 kilograms of steam to water. Can you see that? Steam to water. Calculate the specific latent heat of vaporization of the steam. Vaporization of the steam. So now here, what are we supposed to do? We are looking for the specific latent heat. So we were given the Q, which is our quantity of heat, and we were given the mass. So we can easily look for our formula here. Q equals to NL. We are looking for L. So L will be what? Q over N. What is our Q? Give it to us in the question. 1, 1, 3. 1, 2, 3, 4. Over what is the mass? 15. So let me use the calculator. 113. How many zeros? 4 zeros. Divided by 15. So here we are having 75,333.3. So our L here is 75,333. Because it is L, that will be joules per kilogram. Is that understood? Any question? Okay, so we'll continue our next class. Take care. Bye.